Hello, Qt fans. What a great moment to be here, surrounded by some of the most passionate, brilliant, forward-thinking developers in the world. Today, impossible is becoming possible faster than ever. Generative AI, immersive computing, edge AI devices, cloud-native architectures, and advancements in chipsets are revolutionizing how we think about software development. What we can achieve today was unimaginable just a decade ago. But it's not technology that is changing the world, it's how people use it. The things we create today will shape the experiences of our future. At the center of it all, it's not just about technology, it's about the creators, you. Okay. The developers, the engineers, the innovators. You are the architects of our digital future. You hold the responsibility that the digital world we create is safe, useful, fun, and benefits humanity. Think about it like this. Every day, billions of people are using technologies that were created just like you. A life-saving medical device, a digital cockpit in a vehicle, applications that power industries. That's impact. That's the human side of technology. And that is why what we do matters. Today we celebrate the past, the present, and the future of Qt. Pause for a moment to think about what was the world like 30 years ago when Qt first began. No smartphones, no self-driving cars, no seamless digital experiences. And look how far we have come. The things we use today, just a while ago, were stuff of science fiction. Qt was born from a vision to empower developers to have an open cross-platform framework. That vision took shape in a simple but very powerful idea. Write once, deploy everywhere. From desktop, we expanded to mobile, embedded, and then this idea became reality. That's when Qt became the foundation of seamless user experiences across many platforms. 10 years ago, Qt had grown deeper into key industries like automotive, medical, industrial solutions, where reliability, performance, and ease of use mattered more than ever. Qt was not seen just as a toolkit anymore, but a trusted partner in innovation powering these industries. Today, this community is stronger than ever. We have over 1.5 million developers around the world who have created billions of devices and applications that are used in over 70 different industries. And the next generation is just getting started. We have 35,000 developers learning more stuff in Qt Academy. We have 55,000 educational licenses used in classrooms around the world. And many, many, many more in other channels learning Qt. This is not just a community, this is a force of change that will shape the future digital experiences. Oopsie. Qt has always been there to help push boundaries, help developers to create better software. And today we're going to show you how much further we can go together. If technology is about people, then software is not about functionality, it's about experience. The best human-machine interactions are like invisible thread woven seamlessly into our daily life. And when these are designed well, they feel effortless, intuitive, and natural. So smooth that they simply become reality. Qt 5.0 was launched December 2012. That's 12.5 years ago. Qt 5 has been an extremely successful foundation, and in the technology world, it's a remarkable achievement to have something so successful over so long period of time. Qt 5 has delivered stable APIs, ever-expanding feature set, and always supporting the latest operating systems and hardware versions, so you can have the best toolkit available to build your solutions. Today, we are officially announcing the end of life of Qt 5. The last patch release, Qt 5.15.19, will be released in a couple of weeks. After this final release, we still continue to deliver security patches through the extended security and maintenance offering. This is a big moment in the history of Qt. We want to thank each and every one of you who has contributed to the success of Qt 5 and built all these great solutions that we can use in the market today. Thank you. Having such a great foundation comes the question, so what's next? We have been building Qt 6 for 3.5 years, even a bit longer, to have the platform for the next 12 years or so. So we started with the vision to modernize Qt framework. We introduced C++ 17. There's also option to go to C++ 20 if somebody's already interested in using the latest standard. We redesigned the graphics pipeline with several backends supported, seamless 2D and 3D rendering. We invested quite a lot in innovating and being competitive in the 3D rendering. We introduced OpenXR for new immersive experiences. But we have also reworked a lot of other areas in the framework, in multimedia, connectivity, data visualization, like Qt Graphs. One of the things that we haven't really talked about much, which we should have, is the reality that desktop is going ARM. Apple already launched Apple Silicon a few years ago, and today Microsoft is making a big push to put Windows on ARM. We believe that this is a start of something bigger, and the future for desktop computing will be reshaped. But don't worry, we are here to take care of this and help you migrate to these new environments. Qt 6.9 today offers the industry's widest support of operating systems and the latest version of those operating systems and new hardware versions. Qt Creator 16 ushers a new area of productivity and AI-powered software development. We have not only worked on the high-end applications. For a few years, we have worked also bringing Qt into lower resource-constrained devices like microcontrollers. We have a new graphics stack, Qt Ultralight Engine, which is very powerful and available today. We have the industry-wide support for different microcontroller versions from different vendors. We work very actively with the Zephyr community. We are helping our customers to migrate from Figma design to QML that runs on these microcontrollers. A new thing that you might not have read is that we have also introduced MCU support for Squish. So on MCU testing is available today to help you shave off critical days when you're trying to hit the market. So Qt for MCU today is already established across these key industries: automotive, two-wheelers, commercial vehicles, medical and industrial applications. Creating great user experiences requires a solid technology foundation, and it requires that you have the right skill set people to help you realize your vision. We have created a couple of exciting examples and demos, and we're going to share them with you now. Amazing power of Qt today. Crafting these exceptional user experiences is not a solo effort. You have to have the right technology foundation, the right people, but also every discipline has to work together effortlessly, from design to engineering to testing. We have worked hard in the past few years to build a Qt design studio to help with this problem. In our latest version 4.7, we introduced a great new functionality called Design Viewer. This is a functionality that helps to share UI concepts, designs, and projects within your teams very effortlessly. What that means is that you just need to send a web link. The counterpart doesn't need to install Qt or Design Studio. They just click the link and they can run the design live in any modern web browser. This is powered by Qt WebAssembly. This is a great way to allow more collaboration, faster iteration cycles on your designs, and get feedback to the design's early part of the process. We also felt that there's more we can do to help remove friction between teams. We want designers to also stay in their creative workflow, and that's why today we're introducing a new solution called Figma to Qt. This is a browser-based plugin that allows developers to stay in Figma and convert their designs into running QML application. Let's take a look.
Designs aren't meant to stay on the canvas. With the Figma to Qt plugin, bring your designs to life, instantly, not just pixels, a real working view of your design, rendered for Qt. Launch the plugin, preview your UI live in the browser. Make a change in Figma and see it reflected in real time. What you see is what you'll build. Need code? Switch to code view. Explore clean, structured QML generated directly from your design. Ready to integrate into your application. Design, preview, code, all in one flow. Figma to Qt.
So as you can see, we keep pushing the boundaries to ensure that the great foundation we have with Qt 6 helps you to push boundaries and stay competitive in the marketplace. Faster, flexible, scalable. We can all see how fast the world of technology is evolving today. New platforms, new paradigms, new devices, new chipsets. How are you supposed to keep up, ensure that you're competitive in the marketplace? If you look at the early days of Qt, the computing platform was basically desktop. We called it Wintel, Windows and Intel. Very simple environment. Today, the computing platform is already much, much more diverse. But there's a challenge. The fragmentation is going to accelerate. We talked about desktop going ARM, and this is just a start. I think that the desktop computing will be changed a lot when we move forward. RISC-V architecture is replacing ARM in some markets very rapidly. Due to these political tensions and trade wars, we are starting to see a big technology divide happening between Western world and China. We are already seeing these new technology ecosystems emerging very, very quickly in the Chinese market. Some of the software platforms are based on Linux, so Qt can run there. There are new UI paradigms and multimodal interfaces where AI is playing a role. We are starting to see a lot of advancements in XR, AR headsets, creating new immersive experiences. So unfortunately, the fragmentation will continue and accelerate. We at Qt, we embrace this fragmentation because at the core promise of Qt, write once, deploy everywhere, this is our responsibility to help you address this fragmentation. So how are we going to do that? We believe that the technology should be a safe bet, not just for today, but for the future. We are working very hard to try to understand where the world is going with the help of you, so we can build these technologies into Qt, and they're ready there when you need it. To deliver on this promise, we continue our open tools, open framework strategy. We talked about this already a year ago in the World Summit. We know that Qt developers often work in diverse technology stacks, and we embrace that. We are expanding into these ecosystems like we discussed with the Figma ecosystem. A year ago, we talked about Qt Quick on Android. And we want to make Qt more interoperable than ever. On the tooling side, we know that developers prefer their own tools. And again, that's a great thing for us. We want to ensure that whatever IDE you choose, Qt development can be seamless or effortless. Whether it's Visual Studio Code, Sea Lion, or any IDE that can speak QML through the language server protocol. Okay, artificial intelligence. This is the buzz in the market today. We all read advancements every day, how fast things are moving forward. AI is a very powerful force. It's very fast. But we at Qt feel that there has to be always a human in control. I read a great slogan yesterday, and I want to share it here today, and it goes like this: AI is good, human is better. And this is what we believe. We believe in human-centered development process where we harness the power and the speed of AI, but we keep the human in control. Having said that, I would like to invite Peter Schneider, our resident AI expert, to share a vision of agentic development process.
Thank you, All right, let's talk a little bit about agentic AI. So I'm a product manager here at the Qt company. I'll look a little bit at AI stuff. So I have the pleasure to talk a little about agentic AI here. I want to show you a live, well, not a live demo, a demo of real software. Let's call it like this. So JP talked about, we at Qt believe that the human stands in the center of software development, now and in the future. What does that mean in the time of agentic AI? Well, we can debate a lot of time among you developers whether Gen AI should ever write code for production. Having talked to many of you developers, many of you have said you don't want Gen AI write your code. But then again, there's a lot of buts, right? You're okay with having it writing your code documentation, your unit test cases, and as a matter of fact that many of you use Gen AI to get expert help. Stack Overflow traffic is decreasing, and is decreasing further as we speak. So we are using Gen AI, and you're getting help. We at Qt, we believe that Gen AI will play a role in every single phase of the software development lifecycle. And I want to show you a little bit how that looks like. I want to show you that based on one workflow. One workflow working from essentially a Figma design all the way to a Squish test case. Many of you have tried AI tools like Cursor, Copilot, Qt AI Assistant to get help originally with writing code. But these AI tools have gotten much more complex, and they're doing much more things. They have become, and many of them introducing now things called an agent mode. And an agent mode is essentially where an AI tool is doing multiple steps to complete a certain task. So they are starting to handle complete workflows as we go forward. And this is pretty much what I want to show here briefly on real software, prototype software that we have built. And I will show you exactly in this sequence. In reality, these agent modes or this agentic AI could run in sequence, in parallel, or in a loop. But for the sake of simplicity, I keep it now one piece of agent at a time. So I will show at least 5 different agents that are working together, converting a consumer drone UI into running code that at the end of this, my short bid, you should be seeing running live. So let's start with a Figma design. Like I said, this is a consumer drone UI that you will see first. I'll start with Figma, and then we're working ourselves into Qt Creator and the prototype software that we built particular for this event to show you agentic AI using the latest Qt AI Assistant functionality. So let's start with the design to QML agent. That one, as you can see, now we are having the consumer drone UI. It has this throttle, it has this return to home button. And then you can save it as PNG. I'm also exporting now the metadata with a JSON plugin. And having done that, I move over to Qt Creator, where the Qt AI Assistant is running. And here I'm using a special / command called /create. And what happens now, essentially, the /create will trigger this whole workflow that you see initially illustrated. So first thing I'm doing is essentially, and I recorded this a few days ago, so I'm picking out the metadata that I downloaded from Figma, assign that, then I take the PNG data, and that's all the data I'm going to give one large language model. And this is, again, all the software that you're seeing be created is done actually by a large language model, and we're using, for this demonstration, most of the time Anthropic's 3.7 Sonnet to create the software. So what it will start now, it creates now first a Qt project and assigns then for each of these UI controls that it finds the sliders, the switches, the buttons. It creates now dedicated custom components and links them together to larger groups and then creates also one main file. So you see it now running through creating all these different components that it sees in the UI and sees in the metadata. And it starts creating now for us a complete Qt project and summarize it. So at the end of the first agent, this was the design to QML agent, using a real prompt, using real software, it created a software. So what you're seeing us here is essentially like the main file. That's putting all the background there to the image, but putting all the pieces together in its containers. Then we can dive in, for example, it creates also a template for a drone button. So it has created project, so you have the button. And then, for example, for the camera controls, it created then as well, using the template, it creates the different capabilities. So now, this was all created. You've seen it, this is in real time, what you've seen, so it doesn't take much time. Is that the ready code? Of course not, right? But it's a pretty good start, right? It even has updated the CMake file and added these resource files together. So this is a rather convenient starting point to bring your expertise. So this is the first place where you as a human might be now trying to improve what has been done, trying to add maybe for more components, organize it a bit differently, but you've got a pretty good starting point. But what do we do typically as developers when we have the first iteration of software? Well, we're asking a colleague, a peer, to review our code. 4 eyes principle. So in the world of agentic AI, what actually might happen, what I will do now is in the code review agent, I will ask another large language model to review the code of the first large language model. And just to keep it interesting, I'm going to use DeepSeek version 3, so friends from China, to review the code from the West Coast from Anthropic. So this is the next agent that I will start now. So what will happen now is essentially DeepSeek will look now at all the QML components that have been done and will create for each of them a review file, writing me comments, inline comments in it, summarizing its reviews, comments. So it creates then for all these documents, QML documents, a separate review file that I can look at separately. And then judge whether I like the comments, the new code that's been suggested as improvement, or of course, take only parts of it into the production then later. This run, only the first one example was real time. This runs now at 10 times speed because the DeepSeek API is throttled quite a lot, so we would be sitting here 5 minutes looking at this. That's another reason why I'm doing this in video, not live. So this takes roughly 5 minutes to compute through, but at the end of it, we have review files, right? So then we can go and look at the review files and say, okay, interesting suggestions. You found some things that could be improved. I agree to some, I disagree to others. But anyway, you get an idea. So this is like an artificial intelligence peer-to-peer review. But is that enough? Of course it's not. This is where your expertise, your software architecture knowledge, your experience how to write good cross-platform applications, high-performance embedded devices, good-styled projects comes into place. You need to make the decision, do you want to change the color of the camera button just by changing the color? Do you want to use an image? Do you want to use a shader? This is where your knowledge comes in. We are simulating this now in this demonstration in between the step that we've just seen in terms of the agentic AI code review towards the next agent running. So in reality, this was several days of a software developer to get us to the next level. This is, again, another place where we believe the human is in the loop and has to be. Not only now, but also for a very, very, very long time. So, but let's move forward. Let's call the next agent. The next agent, and the next 3 agents actually, they could run in parallel in theory, but since I want to show you this for live, the next agent is already one of the existing functionalities with the Qt AI Assistant. It creates unit tests, Qt quick test cases, So we are just using the existing function of the Qt AI Assistant to create unit tests, and we are calling that for every QML component that we've seen. So let's get started. So this is again Sonnet behind it. And what we're doing now, we are sending every QML component that we have, sending it up to Sonnet and asking it with our prompt. And if you want to see the prompt, you can join me in my afternoon session. I will explain you more about what's the real code that has been shown here and created, and what is still simulated at this stage. So essentially what it's now doing is creating all these test cases, and except the first one, I'm fast forwarding again by 10 times. This takes real time, roughly 2 minutes. And there you have it. Then ultimately, you have then all your test cases for your QML component. So you got your unit test cases. You might modify some of those, which for example, if you're opening now one of the, for example, the button test file, you see that, okay, I want to fix something small, again, human in the loop. But otherwise, if you look at it, it has a signal spice, so it checks the signal handlers, it does the property checks that I want to do, and it also checks whether the signal handlers fire when they're supposed to. So again, how much time would that have saved you compared to if you're doing it yourself? This again is existing functionality. We just tied it into this agentic AI workflow. So the next functionality is a little bit on the experimental side. We just built it for this purpose, but we know that it roughly works. So now we have code, working QML code that we think is the right answer for our first iteration. We've got the unit test cases. So the next thing we want to do is not only test the business logic of these components, but we want to do graphic user testing. And there's, of course, a superb product from the Qt company called Squish, which can do that for us. So the next thing we will do is actually create the Squish GUI test case. So again, we're taking all these files. So we give all this context, all the QML files, and the CMake file. We give that to, again, for Sonnet, and ask us, can you create us a Squish test case for all these components that you're seeing? And that's essentially what we're doing now. So I created now just one test case. I mean, of course, you can ask it simulate different flows and go through the UI in different orders. This creates just one Squish test case. But you see here in the Python script that it clicks on everything that is there. For things that change values, for example, a slider, it does then a mouse drag. So you have your first test case, and you can create then from there on variations. So what you could do then, this can also create the object map behind in the background. So what you can do then is, for example, take this script, and if you want to, for example, you can use then the model context protocol. You go to the CLI, to the command line interface. You are using a model context protocol to fire off the Squish runner, run it out of the IDE, and see the results of this test file. I mean, we've written a short blog post online how to do this, for example, from an IDE. So again, we have now code. We have now multiple test cases for different functionalities. What's still missing? Well, of course, documentation. The documentation is another agent that I'm going to fire off now. This is, again, existing functionality with the Qt AI Assistant, so we're just tying it into the workflow. So next thing we will do is that we will trigger off the documentation workflow. And that's essentially taking, again, every QML file, looking at the prompt, what it needs to do, ask Sonnet, can you create me the documentation in Markdown format? And then it noodles through all these files and creates us the code documentation as we, again, just the first one was real time. The other ones are sped up by 10 times just to make it faster as you get as you get the point. Moving through here, through the code documentation, we essentially, this completes the actual workflow. So what we have now is created, I think, 15 QML documents at the end of the show, lots of review files, lots of Qt quick test, unit test cases, at least one Squish test that creates everything, and code documentation that you can then post to your essentially wherever you store your documentation for your program. So yes, I'm taking a couple of shortcuts here, like the test project. You would have that separately and put the unit test cases there, and you would, of course, run the Squish test, the Python script in Squish. But you get the point of things you can do and how this works. And very often, even in the test case, you typically have a human in the loop of adjusting where you go. But this is how far it could go. I still will find many of you that will say they don't want AI to write their code. But if you think about this generating and organizing your workflow, what it takes care of all these boring chores that keep you away from doing what you love, writing software. So this is already possible. It doesn't have to be out of an IDE. It could be running up. You could have Jira organizing the workflow in the future. Like one agent could talk, could be master agent, triggering all smaller agents. Doesn't matter how it's going to look like, but something like that we at Qt believe will be the future. So ultimately, let's compile still, right? I mean, I promise you that this will be ultimately running software. So let's just look at the project view, and here you see this is actually only the source files for the project, so there were review files, test files, and other files there. So, okay, open the compile output. And once I do that, then I can compile the user interface of my consumer drone UI that you've seen earlier in Figma. Remember still how that looked like? So now we're noodling through all these components, and in a sec or two, we should essentially see my consumer drone UI. 3, 2, 1. There we go. So there's the consumer drone. That's a functional UI. That's what we wanted to have in the first place. So now we can click things, move things, and animate things as it goes forward. So essentially, we have a UI that we can work with. All of them accelerated by UI, increasing productivity at places where you choose to, changing the direction of the agentic AI workflow as you go forward. So now, this was just a demonstration of AI, agentic AI. I would talk more about it in my own talk later on, if you want to know more about it. But it shows you a little bit the potential where the future of software development will be. Now, again, we said that we see the human really in the center of software development. And you saw it in particular between the code review and the test creation agent, that this is where the human has to come in. I mean, trying to, for example, Sonnet is doing a pretty good job. It's one of the best LLMs. And having two best of LLMs with DeepSeek playing against each other, trying to figure out the best code works really well. But you will agree, if some of you have looked at the code, it's not ideal. So you need to be involved, and like I said, in between these two steps, there were multiple days of software development to get to the final level really involved. But it does help. It does make things faster. And ultimately, let's remember, AI is good, human is better. Thank you. And with that one, back to JP.
Peter talked about how AI will boost the software development process. We have a couple of other AI-related prototypes here at the show. They are outside in the R&D section, so please go and have a look. The first one is a demonstrator of a Qt AI inference API. That's a solution that helps you integrate AI frameworks and LLMs into your applications much easier. And the other one is a demonstrator where AI is generating Qt Quick 3D scenes. Very impressive stuff right outside the doors there. Most projects don't start from scratch. We know that the world is full with software. You have to reuse, you have to adapt, you have to integrate and evolve. This is why flexibility and adaptability are critical. And this has always been the core design principle of Qt. We provide a scalable, flexible framework. It can work in the low end, high end, address different kinds of external changes or your own innovations that help you to integrate and create a competitive solution for your markets. AI isn't the only one accelerating the development. So we have a program called Qt Accelerate. And this is a program where we try to help you to go from a vision to a running product much quicker. We have pre-built templates that are customized for different industry use cases. So with this package, you can get going very quickly, integrate to your hardware, and start to realize your vision in a functional product. We have a 5-day boot camp, so if you're interested, come and talk to us and we'll get you going. Our goal is that you never have to start over. Something has gone horribly wrong if you have to start over. We talked about new fragmentation happening, new technologies emerging, and this is where we are trying to anticipate the future, build these technologies into Qt, so when you need it, it's there, available, and you can move on and build your solution. And this is a joint effort. We of course want to hear from you where you see the world going so we can evolve together. So we all read from the internet how much AI is generating code, how fast it generates. People who have no idea of software development are creating applications. And it's here to stay. We want to harness the power of AI. But the technology is changing at unprecedented pace. And with this pace comes the critical question: how can we ensure safety, quality, and security in the solutions we deliver? So what we need is more intelligent software quality tools to help you ensure safety, quality, and security. We have a portfolio of tools that we are advancing rapidly. We will introduce an AI assistant in the Squish in the next couple of weeks, so stay tuned for that. In the functional safety, we have Axivion, and we have also enhanced that solution to support CUDA. So we have a safety rule set built for CUDA solutions. So this is bringing this advanced static code analysis and architecture verification for high-performance environments. Somebody told me that there is a regulatory tsunami coming, and we can all see a lot of talk about cybersecurity. The EU CRA is already in effect, and we are working very hard to understand what we can do to help you to be compliant with these new regulations. There are similar cybersecurity regulations in other countries. There are a lot of industry-specific requirements that we are also following and trying to see what we should implement to help you pass these requirements. And it's not about just security, it's about future-proofing. We made a change to our LTS promise with 6.8. So our LTS promise now is 5 years. And with this, we're trying to help you navigate these tough requirement and compliance requirements with this longer-term supported release. We also have introduced extended security maintenance that when you're using an older version of Qt, we are still providing security patches and helping you to address these concerns and regulatory requirements. In today's software development, it's not about speed. It's about resilience. It's about adaptability. It's about anticipating that something will change. How will you build your processes so that you're anticipating that change is coming? You might not just know what it is, but it's coming. The technology world is evolving at a breakneck speed. You have to be prepared for that. You have to anticipate that something will change. Either it's your own innovation or it's an external change. Be ready for that. This is what the winning teams will do. They will anticipate the change and they're ready for it. So those who will succeed will embrace automation, use the power of AI, the power of compute, and invest in the quality assurance from day one. Don't think about it as an afterthought. Build it from day one. Your life will be much easier that way. Qt has never been just about technology. It has been also about you, the developers who use technology. We have had an open source model from day one. That is our DNA. And for 3 decades, we have grown tremendously. We have evolved together with you, the innovators, who have also pushed us to build better technology, and we have all benefited from it together. But we feel that our greatest impact lies ahead. 30 years is an achievement, especially in the world of technology and software, but we want to go further. We talked about us reaching out to other ecosystems. We have great success stories about that, like Qt for Python has surpassed 1 million downloads. We want to continue in this path. We want to bring the power of Qt to the future and build the future framework for other languages as well. So that is why today we're making our biggest announcement. And here goes. So we have committed ourselves to build QML bridging technologies. With this solution, you can use QML and Qt Quick to build the front end on applications that are built in these other languages, like Kotlin, .NET, Rust, Java, Swift, and Python. We want to bring the power of Qt to these other applications. If you want to, for example, do 3D on an Android application, we can do that today. Or if you want to use Qt graphs on some other languages to do data visualization. We are really making QML as a horizontal technology. Let's have a quick look. So we have actually been building a prototype to test it out.
The Qt Bridges is a future technology in the making to enable QML and Qt Quick to be used as the front end for applications built in various languages. No longer exclusive use of C++ or Python. Let's take an example, Rust as the backend and QML as the front end. We bridge the languages together to form a minimal app. Now we use the same Qt Quick code and bridge it with .NET. We successfully use the same front end with multiple languages. Qt Bridges technology will enable a single front-end implementation to be used in any industry, on any device, and with any language.
This is a very powerful technology that we are bringing to these other applications. And if you combine this with Figma to Qt and our AI assistant, we are really bringing a powerful solution to other developers outside the Qt ecosystem, so they can build very modern applications that they have today. With great power comes great responsibility, as the saying goes. The software you're building today will just not shape the digital world, it will shape the world we live in. So one question still lingers. What will you build next? Thank you.